Hey everyone, so in this video, we're going to do another problem or example of partial fractions decomposition. However, we're going to do one small thing. This partial fractions example is going to allow us to do a polynomial division startup. So let's talk about that for a second. So the antiderivative we're interested of is from this integral, x cubed plus 2x minus 9 over x squared minus 6x plus 9. Now, what I want you to notice is the highest power of x in that numerator is a 3. Versus the highest power of x in that denominator is a 2. So since the highest power of x in that numerator is greater than or equal to the highest power of x in that denominator, we get to do a polynomial division to start off this problem. So we're going to see that after we do this polynomial division, partial fractions will continue the same way we've always done it. But we get to do this polynomial division first. So let's start there. So I'll just say polynomial division because 3 is greater than or equal to 2, as in the highest power of the numerator is greater than or equal to the highest power of the denominator. So let's start off with that polynomial division startup. And this is going to feel awfully like when we've done long division years and years ago. Let's talk about this. So first we want to divide x squared minus 6x plus 9 into that numerator. X cubed plus 2x minus 9. And the way in which polynomial division works is we're going to take the highest power of x from that denominator, in this case that x squared, and then we're going to have to ask ourselves, well, x squared times what gives us an x cubed? So we ask ourselves, x squared times what gives us x cubed? Well, an x squared times x will give us that x cubed. So after this, what we're going to do is take that x and then multiply into each of these terms in that denominator. So again, we take x times x squared, and that's going to give us an x cubed. Next, we take that x and then multiply it into minus 6x, and that's going to give us a minus 6x squared. And then lastly, we take that x, multiply it into that 9, and that gives us a plus 9 times x. And at this stage, what we would do is subtract the bottom from the top, just like we would for long division with numbers. Now, one thing I like doing is I like putting the corresponding powers kind of above or below each other. So what I mean by that is we have that x squared term in that second term. So I'm just going to slide what's above it over and just put a plus x plus 0 x squared term there. Since we don't have any contributions from x squared in that first numerator. This is just so I don't make a silly mistake kind of by subtracting the wrong thing from the other thing and that type of jazz. So let's go ahead and just subtract that bottom from the top. So we subtract x cubed minus x cubed, we get 0x cubed. Next we subtract, we have 0x cubed or 0x squared minus minus is 6x squared, so we get a plus 6x squared term. Next we have this plus 2x term, and we subtract from it a minus 9x. So 2x minus 9x, that will give us a minus 7x. And then finally, we have a minus 9, but we have 0 constants in that second term. So we just get minus 9 minus 0. That gives us a minus 9. All right, so we've done one kind of step with polynomial division. However, we're not done there for this problem. And it's because we notice the highest power of x in that remainder term is equal to the highest power of x from that original denominator. So because that power of x in the denominator is not strictly greater than that remainder's power, we get to do polynomial division again. So the way in which this works is we ask ourselves again, well, we have this x squared term. How many times does this x squared term go in this 6x squared term? Or x squared times what gives us 6x squared? And well, that answer is a positive 6 times. Because 6 times 6, or 6 times x squared, will give us that 6x squared term here. But now that we have this plus 6 sitting there, we'll take that plus 6 and multiply onto each of those terms that we're dividing by. So let's go ahead and do that next. So we have positive 6 times x squared. Well, that just gives us that 6x squared term. Next, we have positive 6 times minus 6x. And that'll give us a minus 36x. And then finally, we have that plus 6 times that plus 9. So that'll give us a positive 54. And of course, at this junction, we'll subtract both of these things. So subtracting the bottom from the top here, we have 6x squared minus 6x squared. Well, those things will cancel out. Next, we have minus 7x minus a minus 36x. So we have 7x plus 36x. And that'll give us a 29x. And then finally, we have this minus 9 and then minus a 54, which will give us a minus 63. So our remainder in this time is 29x minus 63. And when we start comparing powers of x, we see the highest power of x in that remainder is an x to the first, whereas the highest power of x in our original denominator was an x squared. So since that power of 2 from that denominator is strictly greater than the power of x in that remainder term, we are done with polynomial division. So what we just found through polynomial division was x cubed plus 2x minus 9 all over x squared minus 6x plus 9 is equal to, well, what we found, x plus 6, and then plus what we have from that remainder term. So that remainder term is 29x minus 63, and we'll put that above our original denominator, x squared minus 6x plus 9. And at this junction, we get to go ahead and do partial fractions. If we revisit this again, because what we're interested in is, well, taking the integral of both sides here. If we focus on some of these terms, this x plus 6, we can integrate in a more straightforward fashion. But now what we can focus on is that remaining rational function term, in which case we can apply partial fractions to it. So check out the next video as we continue with this partial fractions decomposition. But that's all for polynomial division.